I'm Anil Kumar. Welcome to my series on pre-calculus. In this series, we'll prepare ourselves to do better with calculus. First, we'll begin to learn about all the types of functions required to be understood. Linear functions are the very basic, and so we'll begin with linear functions. I'm going to keep this series very short and simple. With the help of just 10 questions, we'll review all the concepts. Before we begin in this venture, let me thank the Sun God for embracing this beautiful earth and providing us with the concept of straight lines. So all the rays from the sun, they're all straight lines, and that is what the linear function is. So let's enjoy the beauty of the sun and then take the 10 questions which we are looking into. I hope you enjoyed that beautiful morning with pink sky, such a rare occasion. And with that enlightenment, let us look into the 10 questions we are interested in solving. Question number 1 is, which of the following statements is false? You have 4 options. I'd like you to pause the video, go through these options, answer, and then look into the second question. Now, once you look into all these 10 questions, then we'll actually solve them, right? So in question number 2, we want to know which one is not a linear function. In question number 3, we are given relation between two variables and we want to understand which type of relation will not represent a linear function. In question number 4, we are given set of points and we need to figure out which set of points will lead to a straight line or a linear function. Question number 5 is to do some algebra with 2 points and find the y-intercept for the line, which is a linear function, right? Question number 6 is you need to now work out a line equation which is perpendicular to given line with a given y-intercept. Question number 7. Linear functions, you need to write a one which is a right bisector of the given segment. So this will recall some concepts which you learned about lines earlier, right? Question number 8 is equation of a tangent line to a circle at a given point. So many of you might not know the answer of this particular question. So in case you know all others, you can always skip to the almost end part and see this answer. Question number 9 here is a word problem. So we have plenty of word problems in different playlists. I'll recommend that you actually look into those playlists and see how to solve problems, real life situations using linear functions, and even how to model the real life situations. So many problems which are based on distance, speed, time, mixture, interest rates are all related to linear functions. I hope this will be useful for you. Now, let's begin with the solution from the question 1 itself. I hope that you must have answered all the 10 questions. If not, I'll recommend you to first answer the questions and then look into my solutions. Let's begin with question number 1, which is, which of the following statement is false? Well, I should have written here statements, right? There could be more than one false statement. So we can have more than one option. Now, as a student, to do calculus, I would like you to think with a very open mind while answering these questions. They are all very tricky questions. They may look simple. Okay. So we have 4 options. Graph of a linear function is a straight line. Polynomial of degree 1 or 0 is a linear function. Constant function f of x equals to 5 is not a linear function. Vertical line is not a linear function. So these are all the options for you. You can answer them now. Now let's try to understand the concept of linear functions and then we'll move on. So I'm going to take some time here to explain all the required concepts, right? So let's talk about linear functions first. Now, any linear function, I'll always represent them that they can be represented by equation y equals to mx plus b. So that is what I'm going to call as a linear function, where m is slope of the line and b is y-intercept. Correct. Now I began with y equals to mx plus b, as at this stage many students may not be very clear about the function notation, right? So let me also tell you a bit about function notation. So in function notation, which we'll describe in another video, we'll actually write y equals to mx plus b as f of x equals to mx plus b. So whenever we write equation in the form of a function, we replace y, the output, right, as f of x, right? So that is a dependent variable, right? So this will be our dependent variable, and x will be the independent variable. Is that clear? Just as in equations of line you understood y is dependent on x, right? So that is to say that if I'm drawing a straight line on a graph, let's make one here. So let me just draw a line here, a straight line. In that case, this point where the line crosses the y-axis, let's say this is a y-axis, this is the x-axis. So this particular point here is called the y-intercept, right? So this point is y-intercept. So here the x value is 0, right? So y value will be b with reference to the given equation. So y-intercept will be 0 for x and b for y value. So this point is b. Is that clear to you, right? Now to find slope, these are two good points to take for a slope, all right? So, but it can be any 2 points. It could be any 2 points. Is that okay? So in general, to find slope, we'll take any 2 points, right? So let's say we have these 2 points as P and Q. Now coordinates of point P are, let us say, x1, y1, and coordinates of point Q are x2, y2. In that case, change in y with change in x, this ratio is called slope. So slope m is basically equal to y2 minus y1 over x2 minus x1. Is that clear? So this slope is also called gradient or slope. Correct? Now if you look into this line, we can say that the line which I have drawn, let me write down here, in this particular line which is rising, we have a slope where m is greater than 0, right? So it's a positive slope. Clear? Now when we talk about positive slope, let's talk about negative slope also. So if I have a line like this which is falling, right? So line like this which is shown here, arrows on both sides, of course. So here the value of m is less than 0. It's a negative slope. Perfect. The line is kind of falling. So whenever you look at the graph, see from left to right. Now, we could also have a line which has zero slope. For example, if I draw a line here, let me just go through this space here. So this line, which is kind of horizontal line, for this line we know that slope m is 0. This is if we have the y-intercept, let's say in this case minus 5, then y equals to minus 5 is the equation since m equals to 0. You understand? So for a horizontal line, let me write down. Slope is 0. Now these are all representative of linear functions. So these are all linear functions. Okay, these are all linear functions. Now, in this particular case, there could be a line which is a vertical line, right? So if I draw a vertical line, then that will not be a linear function. So let me draw a line here. So this line here is a vertical line. Here m is not defined. Here m is not defined, correct? So this line, vertical line, is not linear function. So this vertical line is not a linear function. Now, why? The question here is why vertical line is not a linear function. So that's a big question, right? You need to answer this question. It is a straight line, correct? But not a function. Since for a x value, we have more than one y value. So it is not a function. It fails vertical line test, right? So it fails vertical line test. So all this you must have learned in functions, right? So first we talked about functions, basic functions, right? So in that, what are functions? For functions, we have a unique value associated with every x, unique and distinct, right? But there are many values here for x, right? So y could be 1, 2, 3, 4, minus 1, 2, 3, 4, any value, correct? So this is not a function, and therefore this is not a linear function. Perfect. Now I hope you got all the concepts. And for a vertical line also, you will note that slope is undefined. So m is not defined. This is kind of important to understand. So you cannot write it in this form. M is not defined. So you cannot write equation of this line in the form of f of x equals to mx plus b. You could write this in the form of x equals to a, where a is your x-intercept. That is how you can write this equation, right? But you cannot write it in the form of f of x equals to mx plus b. Now with all these concepts, let's move on and answer all the questions. So first one, which of the following statements is false? Graph of a linear function is a straight line. Not always. True. Right? So which of the following is false? This is definitely false, which people think is not false. The example is a vertical line. So vertical line is an exception. It is not a linear function. It is not a function. That is why. It is a straight line. That's okay. But it's not a function. Second, polynomial of degree 1 or 0 is a linear function. That is correct. So here we have a polynomial mx plus b, right? We could also have here equation as y equals to p. Now here degree is 0. Clear? In this case degree is 1. Important thing. Right? Let me just highlight this. So this is like our cheat sheet where we have all the information packed up. So this is correct. Degree is 1 when the coefficient of x, that is slope, is not 0. But if m is 0, that is it is a horizontal line, in that case the degree is 0. So that is correct. Constant function is not a linear function. It is a linear function. This is also false. You understand? Constant function which is shown here in this line is a linear function. It has a slope m equals to 0. So it is a linear function, right? D. Vertical line is not a linear function is also correct. So A and C are incorrect in our question number 1. So from here you must have got a good idea about the things which we need to be learning before getting into calculus, right? Now let's take up question number 2, and now we're going to move very fast. So question number 2 is, which of the following is not a linear function? Now if you look into these lines, they are all like x degrees 1, right? So, or 0. So they seem to be linear, but which one is not a linear function? So if you look into B, you could rewrite this. Look at B, right? We are given 3x minus 1 equals to 2. So that means 3x is equals to 2 plus 1, or we can say 3x equals to 3, or x equals to 1, right? 3 divided by 3. Now if you sketch this graph, then what do you get? X equals to 1 is a vertical line, where this point here is 1. Do you get the idea, right? So this is your x-axis, that's your y-axis. So we want to really emphasize on the fact that vertical line which is x equals to a, where a belongs to real numbers, is not a representative of a linear function. Now this is extremely important concept, right? And now you also know how to write equation of such a line, right? So if this point is 1, we know it is x equals to 1, because at every point the value of x is 1, right? All other equations are representative of linear functions, right? Now my second question for you here is, write some nonlinear functions. So let this be a question for you. Examples could be, you could write y equals to x squared, that is nonlinear, perfect. You could write y equals to sine x, that is also nonlinear. Or you could write y equals to absolute value of x, nonlinear, right? You could write y equals to 1 over x, nonlinear. So there are so many functions which are nonlinear functions. Important thing here is that functions of the form y equals to ax plus b or y equals to b are linear, right? So these are linear functions. Is that clear to you, right? Now let's move on and take the next example. Relation between two variables is described below. Which of the following will not represent a linear function? Direct variation, partial variation, inverse variation, constant ratio of variables. Now, very important question. Let's try to understand the concept once again. So, on a graph, we are always representing x, the independent variable, along the horizontal axis, and the dependent variable y on the vertical axis. So, when I say direct variation, it means what? Direct variation means that y is proportional to x. That is what it is, or y equals to k times x. That is the direct variation. Partial variation is we say that y is equal to kx plus b. So in partial variation, when x equals to 0, y is not equal to 0. So that is partial variation. To show you on a graph, partial variation will be kind of like this, right? So where this point is b, right? So that is partial variation. Is that clear? A direct variation could be a graph which I could also write like this, right? So I write like this, right? So this is a direct variation graph where k is less than 0, right? But it is a direct variation. So in direct variation, when x equals to 0, y is equal to 0. So that is direct variation. Is that clear to you? Now what is inverse variation? Now inverse variation means that y, when x increases, y decreases. So y is proportional to 1 over x. So that is y is equal to k over x. Now this is inverse variation. How will you sketch this graph? So let's try to sketch this graph separately and try to understand how this will look like. So that means if x is increasing, y is decreasing, and x in this case can never be 0, right? So in this case, x is not equal to 0, right? So the graph of this will be kind of like this. When x is negative, y will be negative. So this is the graph of y equals to, let us say 1 over x, right? So let's be, and this is x, correct? So that is the kind of graph. And clearly, this graph does not represent a linear function, so this is our answer, right? Now let's look into the last one, which is constant ratio of variables. Constant ratio of variables means what? So constant ratio of variables means that y over x is equals to a constant. That is the constant ratio, correct? So that means y equals to kx, right? So that is same as direct variation. Is that clear? So that could be represented by a line kind of like this. Do you understand? So that is constant ratio. So I hope now you understand the terms. Direct variation, a straight line going through origin. Partial variation, a line which is not going through a region, which is a, right? So that is partial variation. Inverse variation is when x increases, y decreases. When x decreases, y increases. So it's a reciprocal graph of x which is non-linear. Constant ratio means that y over x is a constant, that is y equals to k times x. So I hope that is absolutely clear, right? Let's move on and take question number 4. Question number 4. In each of the following, a set of points is given on the graph of a function. Which of the following do not represent a linear function? So many ways to do it. One, what you could do is that you could plot the points on a graph, right? So if you get a straight line, that's a linear function. If you do not get a straight line, then it is not a linear function. That is one way of doing it. So you could do that. The other way to do this is to find finite difference. So we'll use the method of finite difference. So finite difference, so in this case, the first finite difference should be constant. Correct? Now, how to do this? I'll take a one example, right? So let's do the first example here, and then you can do the rest. So we have these x values, so we have x and y values. So what I will do here is that we have these points. So we have x1, let me say x and y values, right? So let me write x values here and y values here for the first one. Okay, so it is 1, and here 1 minus 1. We have 2, 1, 3, 3, 4, 5. Correct? Now we see that the x values are increasing by 1. Correct? So they are increasing by 1. Okay. On this side, how much is this increasing by? Now this is increasing by 1 minus 1, which is 2. Now this is also increasing by 2. This is also increasing by 2. So what I did was, I did y2 minus y1, and we found that this is constant. So linear. Is that correct? So this is linear. You understand? So that is how we figured out that this is a linear function. Is that clear to you? Okay. Now, second method could be, let's do with the second one, which is we have 0, 5, 2, 2, 4, minus 1, 6, and 4. So here we are increasing by 2, right? So we are increasing by 2. So the x value is, so delta x is equals to 2, right? Now let's see the value by which we are increasing y. So here we increase by minus 3, right? So this is minus 3. Now here we did what? We did minus 3. And here we again did minus 3. So we know that the slope is y2 minus y1 over x2 minus x1. So it is minus 3 over 2, which is a constant, right? So this is also linear. Is that clear to you? So that is also linear, right? Now let's check the last one here, which is we have the values which are, let me write down the values here, 0, 1, and then we have 2, 2, 4, 3. So I'm also using different types of methods to explain you. So let's find the slope between these two, right? So we'll try to find what is the slope m, which is we want to figure out what is y2 minus y1 over x2 minus x1. Since the slope should be constant for a line, so 2 minus 1, so we get 2 minus 1 over 2 minus 0, 2 minus 0, which is 1 over 2. Okay. Now let's find slope between these two lines. So that is, we have 3 minus 2 over 4 minus 2. 3 minus 2 is 1. We again get 1 over 2. That is correct. Now let's check the slope between these two lines, points, right? So we get 4 minus 3 divided by 5 minus 4. And that gives you 1 over 1, which is just 1. Now this slope is not matching, right? Do you understand? So that means not linear. So that is the correct answer. Now let's look into the last one. The last one here is for different x values, we have same y value. Do you see that? Minus 1, minus 1, minus 1. So these y values are same, right? So it is constant, which is minus 1. So in this case, we have a graph which will be kind of like this. Do you see that? So the line equation is y equals to minus 1. In this case, m equals to 0. And this, as you can see, is a constant function. Perfect. So that is how you're going to do it. So in the first case, we have a straight line which is kind of rising, right? So at 1, we have a value which is minus 1. So it is kind of like this, right? That is the first line. The second line is a line which is falling. Since in the case of second line, we found that the slope is minus 3 over 2. At 0 it is 5. So it's kind of falling like this, right? So that is the second line, right, which is falling. The third line, all the points will not fall on a line, and so it is not linear. The last one here is a horizontal line, which is a linear relation. Is that clear to you? Perfect. So we have learned the concept of finite difference to figure out whether the set of points are linear or not. We have also seen that on a graph, if we have a horizontal line or a rising or falling line, then it's a linear function. But if the points are not on the line, as it was for part C, it is non-linear. So that's how we could do it. Question number 5. The y-intercept of a line through these 2 points is what? So let's find the equation of line. So we'll learn how to find equation of line through 2 points. In our case, let's say we have A, which is 1 minus 3, and the other point is B, which is 7, 9, right? The equation which we are looking for is y equals to mx plus b, where the value of m is y2 minus y1 over x2 minus x1. So using these 2 points, we have minus 3. I mean, we can use this point, right? Let me write that like this. So 9 minus minus 3 divided by 7 minus 1, which is 9 plus 3 over 6, or we have 12 over 6, which is 2. So we know that slope m is equal to 2. Now since the slope is known to us, now we can find the y-intercept, right? So we'll substitute this value of m here. So we get y equals to 2x plus b. To find the value of b, we can use one of these points. So let's use the point 7, 9. 9 is the y values, right? 9, x is 7 value, plus b. So we get 9 minus 14 equals to b, and 9 minus 14 is minus 5. And so we get the equation of the line as y equals to 2x minus 5. And this value, minus 5, is the y-intercept. That means when x equals to 0, then y equals to 2 times 0 minus 5, which is minus 5. So b is the right option. So as you know, in this equation, b is y-intercept. So I hope that is clear how to find the y-intercept when you're finding the equation of a line. Clear? So that is how we'll be doing it. Let's take up question number 6. The equation of a line perpendicular to the given line with y-intercept as that of this line. So first, let's find the y-intercept. So let's find y-intercept. So we are given the line 2x plus 3y equals to 6. To find y-intercept, put x equals to 0. So if I substitute x 0, we get 2 times 0 plus 3y equals to 6, right? So that means 3y equals to 6, y equals to 6 over 3, which is 2. So the y-intercept for us is, let me write down, b value is equal to 2. So that is the y-intercept, right? So we want to find equation of a line perpendicular to. Now the second condition to us is perpendicular to the line y equals to 2x minus 3. So in this case, we know here the slope m in this case is equals to 2, right? So perpendicular line slope is negative reciprocal. So the slope of our line will be negative of 2 and reciprocal means 1 over 2. So that is going to be the slope. Therefore now the equation should be what? Of our line will be y equals 2. Slope is minus half x, right? And the y-intercept is 2, minus half x plus 2. Now all these equations are given in a different form, which we also call standard form. So to get that, we'll multiply by 2 all of them. So we get 2y equals to minus x plus 4, correct? So bringing them together, because x coefficient is positive, bringing it together, we get x plus 2y, bringing it here. So that gives you the equation x plus 2y equals to 4, right? So x plus 2y equals to 4 is the equation, which is none of them, right? So let me make a correction here. Let me write option E, which is x plus 2y equals to 4, and that is the correct option. Sorry for all these wrong, there must be a typing error somewhere, right? So that is how you get the equation of a line, and this is the equation of a line which is perpendicular to the given line and has the same y-intercept as 2x plus 3y equals to 6. So I hope that makes sense, right? Sorry for that error of not including the right answer here, which might have created many confusion to many students. Question number 7 is, linear function representing right bisector of the segment joining A 5, 2 and B 7, 4 is. You can always pause the video, solve this question, then look into my choices. To find the right bisector, we need to first find the midpoint of the line segment, then the slope, right? So the steps involved are to find midpoint, then we need to find the slope, and then we can actually solve the question. So let's find the midpoint of the line segment A and B. Coordinates for A are given to us as 5, 2. Coordinates for point B given to us as 7, 4. Midpoint is the average value, right? So the formula for midpoint is x1 plus x2 divided by 2. That is the x value, and y1 plus y2 divided by 2. So those are the coordinates for the midpoints. So in this case, it will be 5 plus 7 divided by 2 and 2 plus 4 divided by 2. So what we get here is the points as 12 divided by 2 is 6, 6 divided by 2 is 3. So the midpoint M here is 6, 3. Now let us find the slope of AB. So slope M of AB will be y2 minus y1 over x2 minus x1, 4 minus 2, and 7 minus 5. That is 2 over 2 or 1. So that is the slope of the given segment. Now we need to find the right bisector. That means for right bisector, it is going to go through the midpoint M, be kind of like this, right, and perpendicular. So that is going to go through the midpoint M, whose coordinates are 6 and 3. And the slope for the right bisector will be what? Negative reciprocal, right? So it is minus 1 over slope of AB, right? In this case, minus 1. Now we can find the equation. Since we know the slope and the point, equation in the form of y equals to mx plus b. M for us is minus 1, x plus b, so that is the equation. To find the value of b, we are going to use the midpoint 6, 3. 3 is the y value, minus 6 plus b. Taking b to the left side, we get 6 plus 3 equals to b, which is 9, right? So we get the y-intercept of the right bisector as 9. Now we know that b is 9 for us, m is minus 1. So we can write the equation as y equals to minus x plus 9, correct? So that is the right equation, which is option D for us. Clear? So that is how we are going to get the equation for right bisector. Now let's look into the next question, which is the equation of a tangent to the circle x square plus y square equals to 25 at a point 34 is what? Now you can actually pause the video, try to answer this question, and then look into my suggestions. So here is a circle, right? So this circle x square plus y square equals 25 will have radius of 5, right? Any point on this should satisfy this equation. 0.34 does. So 0.34 will be 3 and 4 will be somewhere here, right? So a tangent means kind of like this. We need to find equation of this line, right? So let us say that point here is point P, which is given to us as 3, 4. How do we find this equation? Well, the concept is that tangent and the radius will be at right angles, right? So this will be right angles. So what we will do here is that we will find the slope O to P, right? So we will find the slope O to P, that means M O to P, right? And that slope will be at right angles to the slope of the line, right? So slope of OP is, this is 0, right? So it is 4 over 3. Change in y value over change in x value. That is the slope of OP. Is that clear to you? So slope of tangent is what? Well, the slope of tangent, let's say M, which is perpendicular, will be negative reciprocal, will be minus 3 over 4, correct? And we know it is going through the point 3, 4. So equation of tangent will be what? We can now write equation of tangent here. Will be y equals to slope minus 3 over 4 x plus b. To find the value of b, we'll substitute point 3 and 4. So 3 is the x value, 4 is the y value. So we get 4 equals to minus 3 over 4 times 3 plus b. Bringing it to the left side, you add 9 over 4 to get the value of b, which is 16 plus 9 or 25 over 4. Correct? So that is the value of b. Now we can substitute this value of b in our equation. So we get y equals to minus 3 over 4x and b is plus 25 over 4. Multiplying everything by 4 gives us 4y equals to minus 3x plus 25. Well, bringing it to the left side, we get 3x plus 4y equals to 25. 3x plus 4y equals to 25. Now, here again, we don't have any of these option. So we'll make this as positive. This is kind of, okay, 3x plus 4y. I'm making this as positive. Okay, now, and then that becomes a right option. So B is the right option. Where we changed the sign just now, we made it positive. 3x plus 4y. So that is the equation of the line in this case, correct? So which will be kind of as shown here, right? So I made an error in typing. So that is what it should have been. Okay. Now let's move on and take question number 9. Question number 9. Anil is starting his own business selling books. His cost for equipment and installation is $3,000 and his monthly average expenses average about $175. If his revenue each month averages $420, how long will it take to reach the break-even point? So what is the break-even point? So break-even point is when revenue equals to expenses. That is what a break-even point is, correct? Now in our case, we have two types of expenses. One is the fixed cost and one is the running cost, right? His cost for equipment and installation is $3,000, that is fixed. And his monthly expenses average about $175, right? So monthly, $175. So as far as the expenses are concerned, we have $3,000, which is fixed, plus $175 per month, right? So let me write this per month, right? And what is the revenue? If his revenue each month averages $420, so $420 per month, so times M, that becomes the revenue. Clear? That is how we are going to get our linear relation. Now here, number of months is something which we need to figure out. So from this equation, we can get the solution. So that's a linear equation in M. To solve this, let's take 175 to the left side. So we get 120M minus 175M equals to 3000, right? So which is 5. From 11, it'll be 4, right? And from 3, it'll be 2. So when you take away, that's what you get. So M is 3000 divided by 245, correct? So you need a calculator to calculate this. Let's say, okay, so we'll get 3000 divided by, you could approximate also, 245 in decimals, it is equal to 12.24. So it is more than 12 months, right? So more than 12 months is required. In the options given to us, we have 1 year, which is 12 months. 13 months will be the answer, right? Since 12.2 suggests that in 12 months, you cannot break even. So it is the 13th month when you will break even. Perfect. So that is how we are going to solve it. Now here is the last question for us to solve. I'd like you to pause the video, answer the question, and then look into my suggestions. Question number 10. A mixture of almonds and raisins cost $150. The cost of almonds is $20 per kg, and that of raisins is $15 per kg. Write a linear function to describe this situation, graph the function, explain the significance of the intercepts, determine the mass of raisins if the mixture contains 3 kg of almonds. Now this is a kind of review of what all we have learned in this. So we are given a practical situation. We are mixing up two things and getting a cost, in this case, of $150. It's like a weighted mean, right? Let's try to understand how to solve such a question. So from this concept, let us say we have A amount of almonds, right? The last part here is determine the mass of raisins if mixture contains 3 kg of almonds. So we'll say let mixture contain A kg almonds and raisins, R kg raisins. Okay. Since we know their rate, right? So we can now form an equation that is A kg of almonds, which is in kg, right? And the rate being 20 per kg, right? So it is $20 per kg, right? So see, when you multiply this, you get amount in dollars. Plus, for the raisins, R in kg, their rate being $15 per kg, right? So that is the rate. So what you get is a rate total amount of $150. So that becomes the equation. It's important to understand the equation. So when you're multiplying amount with rate, what you get is the money, right? So dollars, that is what you get. Kg cancel, so you get money in dollars, and that is what the equation is. So I could write this equation as 20A plus 15 raisins, right, equals to 150, right? Everything is in dollars. Everything is in dollars now. Is it clear to you? Right. Now, that is the linear equation, so that is part A for us. Write a linear function to describe this situation. Graph the function. Now, to graph this function, what we could do is, if r equals to 0, in that case, what happens? This is 0, right? So 20A equals to 150. So elements will be 150 divided by 20, which is 7.5, right? Similarly, we can also substitute the value of elements as 0. So if elements equals to 0, in that case, what happens? In that case, 15r equals to 150, or r equals to 150 over 15, which is 10. Correct? So let us say on this scale, we take elements A along the x-axis, raisins R along the y-axis. In that case, the 2 points which we are thinking about, we'll write A first, which is 7.50, right? Here, we are saying A is 0 and R is 10, right? So let's say this is 10 for us. So both elements and raisins, they are in kg, correct? So these are the variables which we define. So what we get here is a straight line where if we do not use elements, mixture is all consisting of raisins. In that case, we'll have 7.5, 10. This is for raisins, right? R. So raisins will be 10 and elements will be 7.5 kg, correct? So this line represents the mixture constituents, right? So the mixture of elements and raisins can now be shown in terms of this particular line. Clear? So if you use a graph paper, it'll be better actually to do this question. Now let's do part B, which is, we have already done the graph. Explain the significance of the intercepts. Now these are the two intercepts, right? So here we mean mixture is only raisins, right? No elements. In this case, this point means only elements. So that is the significance of the intercepts. Clear? So we have answered part B, that the intercepts will show you that if elements are 0, then the raisins will be 10 kg, and if raisins are 0 kg, then the elements will be 7.5 kg, right? So in this case, raisins will be 10 kg. Okay. Now let's do C, which is determine the mass of raisin if the mixture contains 3 kg of elements. So now we are going to use this equation, and in this equation we know elements now are 3 kg. So let me substitute 3 here. So we get 20 times 3, so what we get here is 20 times 3, so we are substituting here 3 kg, plus 15r equals to 150, correct? So that is 60, we'll take it to the right side. So that gives you 15r equals to 150 minus 60. So raisins will be 150 minus 60, which is 90, divided by 50, correct? So we get our answer, which is 6, right? Which is 6. So it is 150 minus 60 divided by 50. So we get 6 as the quantity for raisins, right? So somewhere here, let's say the point will be 3, 6. Where the elements are 3 kg and the raisins are 6 kg. Does it make sense to you? So that is how, using our function which relates to the given situation, the linear function, we can solve such questions. So for any quantity of raisins we can find elements, for any quantity of elements we can find raisins. So I hope that helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'll be great. Thanks for watching and all the best.